Hello AS, welcome to your final, I'm pretty sure final, I'd like to say, don't want to get your hopes up too much, but I'm pretty sure it is, final flip learning for research methods. So the next thing that we'll go on to after that is biopsychology. 2 or 3 lessons on that, and then we are into some psychological content as you might recognise it. So you're doing really well, you're moving through everything at a nice pace, well done. So some new terms for correlations. Covariables. Correlations do not have an IV and a DV, they have 2 covariables, covariable 1, covariable 2. It doesn't matter which order, which one's 1 and which one's 2. So please do not refer to IV and DV here, it is covariables. IV and DV, we are looking for cause and effect. In a correlation, we are looking for a relationship. So it's just 2 covariables, 2 variables that work together. There is a strong correlation, so that means anything with a correlation coefficient, and that's really important, we'll talk about correlation coefficients in a minute. Anything with a correlation coefficient, I would say, of over 0.7, so 0.7, 0.8, 0.9 or 1 is a very strong to perfect correlation. Weak correlations are say 0.3, 0.2, 0.1, 0.4 possibly, so we can't be very confident that there's a relationship there statistically, so numerically they are not very significant. There is a positive correlation, so as one covariable goes up, the other covariable increases at the same time. So you might find that as height increases, so does shoe size, so that's a positive correlation between the two. Or you might find that scores out of a test increase along with hours of revision. So positive correlation, 2 things go up. And then a negative correlation, as one covariable goes up, the other covariable goes down. So as temperature goes up, sales of ice cream go down. You could be asked to, the couple of different ways that you could be asked to talk about correlation is you could be asked to talk about the correlation coefficient and what information it tells you. Well, it tells you whether it's a strong or a weak correlation by the number, and by the plus sign or the minus sign it tells you whether it is positive or negative. So that's the correlation coefficient that we've just talked about. And then there are intervening variables. So these are variables that make it appear as if there is a correlation when in fact there is not. There's another variable kind of in between the two which is influencing the relationship in some way. So it looks like A causes B when actually it could be C, so a different thing altogether we're not measuring. Correlation coefficients, so there you go, you have exactly. So 1 is a perfect correlation, and I'm not quite sure what would make a perfect correlation, something that's probably very artificial and man-made. And then there is a high or strong. Strong would be better, ignore the words high and low. It's a strong positive correlation. So 0.8, that's a correlation coefficient. You can see there's no plus in front of it, so you can assume it's positive, or there will be a plus sign in front of it, either one. As long as it's not a negative sign in front of it, you know it is positive. So there's a strong positive correlation of 0.8. There is a weak positive correlation of 0.3, so that means there's not a great deal of correlation. There is no correlation. There is a weak negative correlation of 0.3, minus 0.3, a strong negative correlation of minus 0.8, and then a perfect negative correlation of minus 1. This is something that is so simple that always trips students up, so please make sure that you're ready for it. And there you go, with positive correlation you can see the 2 covariables. Positive, they both increase, whereas in a negative correlation one goes up and one goes down. Both of them still show a relationship, and both of them still allow us to make predictions. No correlation does not help us with anything. So, thinking about intervening variables, the question here is, a recent survey shows that 100% of people who drink water die. That's a fact. So we would say there is a correlation between drinking water and death of 100%, a perfect correlation. If you drink water, then you will at some point die. Sort of a correlation, not quite obviously, but you get the idea. Is that correct? Is that a valid statement? Well, of course not. There's the intervening variable of the fact that we are mortal human beings. We will all die eventually, and we all have to drink water. So here what we're talking about is the idea that correlation does not equal causation. So correlation does not mean cause and effect, one causes the other, IV causes DV. It just means that there is a relationship between the two things, but it doesn't mean that one causes the other. So some examples here of my favourite website, spurious correlations, which is a correlation that means it's a little bit dodgy. It makes it look like there's a relationship between 2 things that there isn't. is, you can see there's a correlation coefficient of 66% or 0.6, so a positive correlation of 0.6. So there's a fairly strong positive correlation between the number of people who drown by falling into pools and the number of films that Nicolas Cage appears in. So does Nicolas Cage need to stop appearing in films? Maybe, but that doesn't mean that it will reduce the number of deaths by drowning. There is some kind of intervening variable, or it could just be at random. It's not, it doesn't, one thing doesn't cause the other, they just have some kind of relationship. This has an extremely strong positive correlation of 0.9, so that the amount of cheese consumed is related to the number of people who die by becoming betangled in their bed sheets. Clearly there is no relationship between cheese and bed sheet tangling, as far as I can tell. It is just that there might be an intervening variable, so another variable could explain both of those correlations that I can't think of in the slightest, or it could just be statistical fluke. The age of Miss America correlates with murders of steam, hot vapours and hot objects, so again another really strong positive correlation of 0.8 for that one. So do we need to be really careful and positive correlation, so reduce the number of years that the age of Miss America to protect other Americans so they don't get killed, they don't get murdered through steam, hot vapours or the use of hot objects. So we need to insist that they're they're a very young age, and we could never ever have a Miss America at the age of 25. No, correlation does not equal causation. So there you go. What else might have caused this correlation? So therefore we've got intervening variables, which we talked about before, so other variables that might have caused it. So what I'd like you to have a think about in your flipped learning books, and I want you to tell me about, is what might be the intervening variable that causes a relationship. So if there is a correlation between the amount of ice cream sold and deaths by drowning, generally those two things is a positive correlation. As ice cream sales go up, death by drownings go up. What might be another reason of explaining why that happens? Why might people want ice cream and also be close to water? So what might be the other variable that could explain that? Shoe size and reading performance. So do we all need to stretch our feet so we have massive feet so we can be amazing readers? No, of course not. As shoe size goes up, why might reading performance go up as well? Not because there's a relationship between the two, but there's another intervening variable. And then the number of doctors in the region and the number of people dying from diseases. Should we ban all doctors from certain regions and therefore it would stop people from dying? No. So what is possibly could be the reason why there are a high number of doctors in a particular area and a high number of people dying from diseases? And then teachers' salary and the price of alcohol. So do teachers getting paid more as we get pay rises, does that cause inflation of alcohol? Does it increase the amount how much alcohol costs? No, there must be another reason. So what is the variable between teachers' salary and that increases teachers' salary, and also the same thing that increases the price of alcohol? What thing is happening at the same time? Okay. My favourite other spurious correlation is there is a direct correlation with the amount of pirates in the world and global warming. So have a think about that one. Is it that we should introduce back pirates and therefore that would reduce global warming? Do pirates protect the world from global warming? No. So what was it? There are lots of different ways of thinking about correlations and how they don't link with causation. So sometimes it could be that there is a causation, A could cause B, but also when we're looking at correlation it could be that B causes A, and we'll look at examples of that. It could also be that C, an intervening variable, causes both of the other covariables and therefore makes it look like a correlation, and also it might be that the two things are not related in any way whatsoever. So the question would be, does Facebook improve A-level grades? Well, it might be that using Facebook does increase people's grades. If you join the Tutor to You psychology Facebook group, then that might be the case, because they have some excellent things on there. It could be that better educated students use Facebook more. So instead of Facebook increasing grades, it could be that better educated students use Facebook more. So it might be B causing A, the other way around. There could be an intervening variable, that more access to computers has improved A-level grades and has made that more people can use Facebook. Or it could be the two things aren't related at all. So more online access has boosted Facebook and better teaching has pushed up grades as well. So C, where we're talking about intervening variables, that's C, but there are loads of other reasons that it could look at causation. I would like you to suggest a correlation which might appear to be positive or negative, however can be explained by an intervening variable. So think of a correlation, either positive or negative, I don't mind which, that looks like there's a strong positive correlation or strong negative correlation, and then explain it through an intervening variable for me, please. And then evaluations of correlation, and then we're going to have a very quick look at peer review. So strengths, what I'm going to do is I'm going to give you some statements, and I want you to decide if this illustrates a strength or a weakness of correlation, and what strength or weakness it illustrates. So have a think about how we've been structuring strengths or weaknesses. A strength is this. A strength is this is a strength because I want you to think about how we have been structuring those and what these examples illustrate. So example 1, I want to be sure that a correlation I have is correct. I repeat it. Is that possible? Absolutely is possible. So what does that tell me about correlations and if we've got our hands on the data? Example 2, I want to find out if there's a relationship between the amount of the severity of lung cancer or the likelihood of getting lung cancer and smoking. Which am I more likely to be allowed to do? Conduct a correlation, so where I look at people who already smoke or how much they smoke and then compare that to how likely they are to get lung cancer, or am I going to be allowed to conduct an experiment where I identify 20 babies who are exposed to smoke, so I'll pump smoke into their nurseries every night, and 20 I don't, and then record incidents of lung cancer later on. So what does that tell us about a correlation and what it allows us to do? And then weaknesses. Example 1, I want to explore the relationship between intelligence and creativity. I measure the circumference of people's heads for intelligence and their ability to trace a picture for creativity. What does that tell me about the way that I am measuring the covariables? So we can still do a correlation, but if the covariables aren't measured, the measurements lack validity. Is that a problem? And then example 2, there we go. There's a negative correlation between the number of pirates and world temperatures. Psychologists conclude that pirates prevented global warming for years and we need more pirates. Is that the case? Is there a relationship? Is there a relationship between pirates and global warming? Is there causation between them? So is it that one causes the other, or do we need to consider, do we need to think about something else? Can a correlation tell us about causation? And if it can't, how helpful is it? Okay, and then finally peer review. So peer review is something you need to know about, and a lot of this information is taken directly from the mark scheme, and you could be asked about it, and I think it's very likely that you will in the exam, because in previous years this has not been a well answered question. So please make sure that you're aware of it, because they like to put questions that have been answered poorly back in. So peer review is the process by which psychological research papers before publication are subjected to independent scrutiny by other psychologists working in a similar field. So that's the exact wording from the specification. What that means is that before we publish research papers, so before we put them into journal articles, before we send them out to the general public, they are looked at by somebody who is completely independent of the author, so there's no bias there at all. We do scrutiny, so we look over them carefully, of psychologists, of peers. So peers just means someone of a similar, working in a similar field, of a similar level of knowledge in the area that you're working in. 3 things can happen. They can be accepted. Yep, that's brilliant. You can publish that. They can be sent back for revisions. It's pretty good, but you just need to think a little bit about this conclusion you've drawn. It's a little bit extreme, claiming that pirates, we need more pirates because of globalization. You need to acknowledge that correlation doesn't doesn't equal causation, or they can be rejected outright. No, this is terrible. You definitely, absolutely can't publish this. So what do the people in the peer review do? They check the validity of the research. They question, does the research measure what it claims to measure? And we can test validity in a number of different ways, and I'll talk to you about those probably a bit more in AS, or possibly, in A2, or possibly in AS if you get through everything and you're lucky enough. Making a judgment about the credibility of the research. So how credible do you think it is? How reliable do you think it is? Do you think it's relevant or not? Assessing the quality and appropriateness of the design and the methodology. So was this well designed? Is the methodology good? Well, if it's a lab experiment, you can talk about problems with lab experiments. If it's a field, you can talk about that. If it's independent groups, you can talk about that. So it's essentially evaluating whether the methodology was whether it was well conducted. And they will also assess how original the work is and whether it refers to relevant research by other psychologists. So if it doesn't make any, if it hasn't got a strong background in relevant research by other psychologists, then it's probably not very credible. It's not very reliable. So we wouldn't be prepared to publish that. And also how original it is. So if it's been done 800 times before, we're probably not that interested. We're probably not going to waste money publishing it, only if it moves the body of research on in some way. And then finally, what is the purpose? Well, the purpose of a peer review is that weaknesses will be identified and addressed. So if you put in a piece of research or know that it is going to be peer reviewed, you're probably going to identify the weaknesses and address them before they go in, or if you don't, they'll be sent back and gone, no, you've got to address them before you do them again. It prevents the dissemination, so the spreading of irrelevant findings. So we don't want anything that's not new or interesting or relevant in some way. Unwarranted claims, so pirates protected from global warming. Unacceptable interpretations, similar sort of thing. Personal views, so have we got any personal bias, and then deliberate fraud, and there are some examples of deliberate fraud that would have been caught if peer review was in place. Judge the quality and significance of the research in a wider context, so the psychologist knows all about the area, so it can judge whether it's useful within a wider context, whether it's significant or not. We've already had 3 million reports on this, it's not very significant. They can also personally judge the quality when they're in the field. They know, oh, you used that kind of brain scan, that's a bit dodgy considering what we're looking at, so they can talk about that. And published research can be taken more seriously because it has been scrutinised, so it helps uphold the reputation of the journal article. And that's it, really. Excellent. Well done for surviving research methods. You'll probably have one more research methods recap and possibly a little bit of a mini mock on that, but you have got through one of the trickiest sections of psychology. Well done.